up today on a Monday morning. We got a kind of exciting agenda for the next few days. We did try something a little different, spread it out over a few days, over different times to make sure that folks could join and get around their kind of normal regular scheduled meetings, things like that. But so first off, I just want to kind of go around and just, it's too big to kind of introduce everybody, but I'm going to ask kind of the lab leads here for the Helix Plus team to introduce their team that will be doing presentations over the course of the next few days. So first off, my name is Jason Fuller. For those who don't know me, I'm a engineer at Pacific Northwest National Laboratory. I've been part of the Helix team for about 5 years now, and then the project manager for this particular effort around it. We also have on the phone Allison Campbell from P&L, who will be doing a presentation later this afternoon on how to get started with Helix. Brian, do you mind introducing the NREL team?
Sure. My name is Brian Palmentier from the National Renewable Energy Lab. I'm a research engineer and group manager there. Also been involved with the Helix project from the beginning. It's been great working with this multi-lab team. In terms of folks you'll hear from over the course of the next few days, I'll be organizing the sessions tomorrow around the use cases, during which time you'll hear from a number of other NRELians, as well as folks from across this call. But on the NREL side, you'll hear from Adel, who is leading the use case on T&D co-optimization. You also hear from Brian Sergi, who's coordinating our portion of use case on the natural gas. And then later you hear a bunch of different people from NREL. I'm not going to go through all their names on our sort of lightning round use case session at the end of the second session tomorrow. In addition to that, you'll hear from our colleague Deepak Krishnamurthy, who's been part of the core development team and involved with Helix from the beginning as well. He'll be talking with a number of different pieces on the core development team side and usability side.
Thanks, Brian. And Phil, could you quickly introduce folks from the Livermore side?
All right, I'm Philip Topp from the Lawrence Livermore National Laboratory. I've kind of been the lead system architect for Helix, managing the Helix repository and one of the core developers for Helix. I will be leading the developer session on Wednesday and kind of seeking feedback on where we should focus on next. You will also hear from Ryan Mast. He's been also a core developer on this, and in the user session, you'll hear from Brian Kelly, who's been doing some code reviews for us and is managing a related project utilizing Helix.
Excellent. And there's also, didn't mention Trevor Hardy, who's been a key member of this team also and is leading most of the P&L team. He has actually ended up having to go out sick this week, so unfortunately he won't be able to present his material, but we'll do the best we can to cover it as we can. So so let's go ahead and dive in. A couple little kind of just early things to start from, just some ground rules, just because this is these virtual meetings, it is good to just kind of set these out up front. If you're not familiar with Teams, up across the top right banner, there's a couple things. I really encourage people to ask questions. This is really meant to be a conversation. I think there's a couple sessions, maybe this one will be a little bit more kind of talking to you. And I think maybe the use case sessions will be a little bit more talking to, but we encourage questions. We encourage conversations on all these sessions. You can use the chat window, you can use the raise your hand function, and feel free if you want to use your video when talking. It's always nice to see your face also. But that's not required. If you aren't speaking, please go ahead and just mute your phone. If we pick up backup noise, I'll be muting people, but for the most part, if you can yourself, that would be great. We're going to do all of our can to stay on time and end sessions on time, but any conversation, we're happy to continue after the sessions are over. This the whole idea of this is to build a conversation in the community, and so even if we run out of time, that doesn't mean we will have to necessarily end the conversation. So. So again, feel free to talk. That's really the main point. So what's our agenda? At this point, this should have gone out to everybody through a Word document with links. Each of these sessions does have a different link in it and a different meeting, so make sure that you're not trying to use the same one. If you do have a desire to have a calendar invite with the links, just please go ahead and reach out to myself or to Brian or to Dee Marmo, who sent out the original email. She does have access to Outlook links and can send those to you so that you can add them to your calendars as necessary. But here's what the sessions are for today. So I'm going to basically kick off today with just kind of an introductory kind of here's what's going on. Here's the kind of the big picture of what we're doing and where we are. At 11 a.m. Here, and this is all Pacific time. So about 2 hours from now, we'll be doing a getting started with Helix. This is really a beginner session for somebody who's really brand new to the tool and wants to learn about how all these pieces work together. How do you install it? How do you get it going the first time? So that session will be for someone who's basically never really used it before. Tomorrow morning, from 9 to 11, again, Pacific time, we're going to go through a couple sessions of use cases. These are going to be kind of some rapid fire sessions where we're going to be just basically introducing folks to all the different use cases that we're aware of or that folks were willing to share. That doesn't mean we got them all. In fact, I know we didn't. But the idea of having these sessions is really to kind of start to enable people to start talking about their own use cases and finding out the people who are in the same area and want to have the same kind of conversations and collaboration. So it's designed to be a session just to get the information out there and hopefully build some partnerships around certain kind of aligned use cases and things like that. And it's also a chance for everybody to see what's going on and what's the focus right now. As we move into Wednesday, we've kind of got a triple session on Wednesday, spread out over the day. We have a developer session. So Phil, as mentioned, will be leading that. That's really, talking about what's new. What's come out in the last year and a half or so. What's next, and then of course asking you guys, what are we missing? We've got all these ideas and plans and features and tools, but it's always clear that we're always missing something. So we want to hear back from you about what that might be. We'll be going into what we're calling a usability and then a user session, which do have quite a bit of overlap. But these are really designed to understand what is it that in the tools right now that are preventing adoption, preventing you from using it. We're going to talk about some of the things that we have been doing to try to improve that. So talk about some of the documentation, some of the introductory features, some of the scripting environments, and a whole slew of other things that we've been adding to the tool to try to make it easier to use and for people to get started using it. So we'd like to introduce those to everybody and then hear back about what we might be missing. I'll mention that all these sessions are designed to be standalone. So just come to the ones that you're interested in. I understand that not everybody's interested in development and maybe not everyone's interested in getting started with Helix and things like that. So just choose the ones that you're interested in and we'll try to make those as standalone as possible. We are recording all the sessions and we'll try to make them as available as fast as we can for anybody that misses them. So as I mentioned, just contact Dee Marmo if you have a need for any of these calendar invites. So let me just start in with a little bit of background just to kind of set the stage for where we are and what we're talking about. So really this comes around from the idea that the interdependence between our critical energy infrastructures, particularly for us, natural gas and grid, telecommunications, distribution and transmissions, buildings, DERs, EVs, all these things that are getting added to the edge of the grid or around the grid or across the grid. They're all becoming so intertwined with each other that if we continue to think about just modeling and simulating the power system itself, then we may be missing out certain components of it and certain interactions. And so the idea being that we really need this kind of comprehensive system analysis where we can understand those relationships, dependencies, various constraints that go across the different domains, and then really the joint evolution of these interconnected systems. For us, co-simulation is one approach to that. It's not the only approach. We always kind of mention that this is just one way of getting to that problem that allows us to kind of tackle this with the existing tools, data, and models. Sorry. So when we talk about analyzing these large and complex systems through co-simulation, it's really just a method for unifying multiple models in a coordinated fashion. You know, they may or may not be of similar domains. They may or may not have similar concepts of how time behaves. They're almost never written in the same language. And then, you know, they may be, in our case, we're trying to think about this from a situation where you may want to run it on your laptop on the same computer or operating. You may want to up to a high performance cluster where you might be operating across multiple operating systems or multiple computers across the network, or even across multiple geographic locations. We're starting to consider some of those interactions and things like that. And these interactions, you know, we want to be able to have them express themselves in a way that influence each other's behaviors. So when we start to put these different domains together, how do you basically make those pieces of information move back and forth and cause those interactions? But in the end, what really the big things that happen with co-simulation tools, they essentially manage time synchronization. So basically making all these tools move together through time together, and data exchange. Now there's a lot, each of these things has a whole ton of subcategories and a whole bunch of different little inconsistencies and idiosyncrasies, but in the main essence, that's the two things that we're really talking about trying to do and what we're trying to enable. So just kind of a simple example. You know, if we could talk about something from just a weather perspective, for example, where we're trying to basically co-simulate some kind of Earth system with some weather system. So you could things like humidity, sunlight reflectivity, or you might be, you know, pushing back precipitation or ambient temperatures or things like that. Where these are two different modules, two different solvers, and really the sharing of that information across that boundary enables those two to work more closely together. From a power system perspective, you could think about something like, you know, being able to co-simulate the way that a building or a DER works, or a distribution system with a generation and transmission system, trying to understand how does power consumption and load forecasts change the behavior of the generation system, and therefore how does that change energy prices and even down to the voltage at those individual locations, and then be able to kind of iterate on that capability. And so we'll talk about a little bit about when these are kind of one-way flows and when these are kind of iterative flows throughout our use cases over the next couple of days. And part of what we're trying to solve is this idea that, you know, power system models cross wide ranges of time and space scales. So I always love Brian's slide here, this image that he's put together. What really talks about, you know, that when we're thinking about the power system, we're talking about all the way from microseconds all the way up to decadal kind of studies, and we're talking about all the way down from like the code inside of a single device all the way up to a national or you know, our case a North American scale system, and then trying to put all those pieces together so that when you really talk about how these things align with each other, it's not just these individual pieces working their individual domains, but then combining them across these different time scales or across these different scales, and being able to then learn something additional from that than you could from these individual domains. So just a little history here. So Helix is basically our solution to this challenge, and it's, you know, primarily focused on the energy space. So in 2016, the DOE Grid Modernization Lab Consortium funded the initial development of Helix, which is, for those that don't know the acronym, I still have to look it up every single time, so I made sure and wrote it right here on the right, but it stands for Hierarchical Engine for Large-Scale Infrastructure Co-Simulation. So really focusing on this co-simulation piece, but the fact that it's large scale and that we're looking to be able to do this across different types of engines and different types of simulation platforms. And this was really born from the idea that we had a whole bunch of national labs that were doing a whole bunch of really cool work in co-simulation, but we were all kind of going off our own directions. And so this was the opportunity for us to bring together kind of our best-in-class, best-in-breed solutions, and then form them into a single open source solution that we now provide out to the community and are trying to use across the national lab system in a coordinated manner. Part of that was really the fact that we were able to learn a lot from our own internal investments, and then bring that out and really develop a platform that was structured, had all the key pieces that we're looking for. You can see over here on the bottom right, this is a great diagram that Phil put together early on in the project to kind of help lay out the way that we're slice and dice the system in a way that becomes modular, and we can basically build various components with it, and then transfer those components depending on what we were trying to do. So for example, if you look at the bottom piece here, the fact that we're on a Linux or a Windows machine is separate from basically whether we're operating different simulators. Obviously, those individual simulators are going to have their own challenges on different operating systems, but at least from the perspective of Helix, it doesn't care what those platforms, those are sitting on. In 2020, so last year, DOE released a second set of funding for us, which now lets us focus on less on kind of the deep underlying guts of the tool, but more on the needs of the user. We call this Helix Plus, is the name of the project, and really focus on how do we make sure that this tool can be adopted and is usable and is easy to pick up. What we're excited about for this week is that we've made great progress, and we're excited to share the work and then get feedback on that work and see how we're doing. So just kind of our high-level goals for the Helix Plus program or project over the next 3 years. We're about 1.25 years into that 3-year project, but it was really kind of three areas that we determined that we needed to focus on. One was basically co-simulation methods. That was looking at ways of basically doing scalable integration and iteration. So basically being able to iterate between different federates and to support multi-scale time-scale dynamics and mobile agents. So basically that means that we're able to do various time scales and move back and forth between different configurations. And so if you can imagine like an electric vehicle type simulation where maybe you want to have an EV pop up into the grid simulator, but then all of a sudden it leaves for 1.5 days and then pops back up again. That's what we consider a mobile agent in the system. And then be able to do that in a way that ensures both physical and non-physical interactions. So physical being things like voltage and current, and non-physical being things like control signals and other kind of variables. And then one of the things we really wanted to focus on was numerical convergence. And so we're going to talk about this a little bit through some of the use cases. But as we start to kind of get these tools talking to each other in a way that they weren't originally designed to talk to each other, we start to run into kind of some numerical challenges and how these things solve. So we've been developing different methods and then working with some of the commercial partners to then extend that into how do we interface with the tools as they exist today and help drive that convergence. We wanted to focus on usability. We understand that this is a complex area where you're coming from a domain where you might be looking at, say, a transmissions simulator or solver that has its own characteristics and its own challenges to become an expert at. And then you're going to come in and say, well, but now I need 2 or 3 other domains that are also I need you to be an expert on. And so we're trying to find ways that will kind of help the user make that transition. So part of the things we've been working on are things like automated configurations, templates for standard use cases, scripting methods for various kind of common co-simulation executions. Looking at better runtime tools, whether that be command line or through scripting environments, both for executing the models, but also for monitoring it, debugging it, and then validating it while it's going. You'll see some of that over the usability sessions over the next few days. And then one of these other areas is developing what we call a common domain-based interface. And so really what that is saying that we're in an area where we're not going to have 1,000 tools plugged into this. We have a pretty core set of tools that a lot of folks will use quite a bit. So why not make the interfaces to those look as similar as possible? And so the example I like to use is say something like, if I'm going to use PowerWorld versus PSLF, that's fine. Those tools each have their strengths and weaknesses. That shouldn't matter to us. But what should matter is when that data gets into the Helix bus or a data system, is there any reason why we can't make those 2 tools look pretty much the same, so that if someone comes in and says, well, that's really nice, but I'd really like to run that with PSSE now, can we make that exchange very, very seamless and be able to kind of make those domain interfaces pretty similar across all the different pieces? We'll see some of the progress on that I think the answer is, for the most part, yes, we can do something there. Probably won't be perfect, but we can get probably a really good interface that is fairly exchangeable and compatible with a number of different tools. And then the last piece is really focusing on demonstration, because that's where the nuts and bolts come from. That's where we're basically able to then sit down and say, like, we feel like this is doing something that's of value, and then basically try out these new methods that we're creating, both in terms of the co-simulation, but also usability, and use those demonstrations to do exactly what we're doing today, which is engage the broader community through different meetings, workshops, conferences, things like that, and really start to show some of the value of some of these interactions, and then figure out where those interactions are having some challenges and improve them. I will want to say that we do have a great team. So there's a number of Helix Plus collaborators from the industry and academic side. We've got Avista, Clemson, Delta Star, Eaton, Oncord, NRECA, and WSU, and then the 5 labs that are part of this project: Argonne, Idaho, Lawrence Livermore, NREL, and PNL. And so it's really just an exciting team. We're just really happy about the progress we're making, and happy to share with everybody. So just some kind of progress updates. I'm going to go, this is going to be at a super high level. You're going to get more on these over the sessions over the next few days. One of the big things was performing an external code review, basically to kind of walk through and find out where we had dependencies, what was going on with the libraries. Basically identified I won't quite call it a laundry list, but a long list of issues that we're tackling and working through. A lot of these got addressed in the version 2.x's that have been released over the last probably 6 to 9 months, but some of those had to wait for version 3.0, which we're hoping to release here in the next fully release here in the next few weeks. We've significantly extended the number of tools that can talk to Helix. So here's my kind of map of the most up to date. Some of these, even that are in these kind of, well, this blue color here first is really that they exist. The bolded dark color is that they are being worked on. Some of these you could probably switch these to blue if you really wanted to. So for example, RTOps and RTAG, you'll hear about that tomorrow. That's probably what I'd call finished now. SIMDist is probably pretty close too. A lot of these tools are just kind of, they're really close or are already there. So you can see that there's just a lot of stuff going on, both in the transmission, distribution space, a few tools in the communication space. And then what we found out was it's all these other tools that we wanted to add in that are really exciting also. So a lot of work in the NG natural gas area that's been pretty exciting. We basically built in tools like MATLAB and Octave so you can access those type of things. One of the areas that we're finding a lot of success with is being able to map in just generic control agents. So you hear part of that with the transactive energy work tomorrow. A lot of work with as part of this team on integrating transportation systems through Polaris and Beam and being able to pull those pieces together. So just kind of a lot of cool stuff going on, and pretty excited about how the progress is going. As I mentioned, we released a number of different versions of Helix over the last year. These were kind of the 2.x incremental increases, which were, there were some minor overhauls, but for the most part addressing bugs and other issues. But Phil and his team have been doing a great job getting the 3.0 alpha and beta out over the last 6 months. There was a bit of a delay between alpha and beta because of what we found was a major timing bug. It took us a little bit of time to sort that out, but now that's beat out, and we're moving on from a beta and hopefully a full release here in the next few weeks. So it will represent a bit of a major overhaul for the APIs. We tried our best to minimize any problems with backwards compatibility, but Phil can go over that a little bit better for you tomorrow during the developer session. Part of some of the other work was basically rewriting some of the interfaces throughout the tool to make it much easier to install. So there's a much easier install mechanism now than there was in previous versions. And at least important to us was that we moved our continuous integration testing from Travis CI and now have moved that over into the Azure AWS pipeline. So basically we're doing, as code is committed each day, we're doing continuous testing on it to make sure that it's still staying stable and that we're be able to address previous use cases as we're going forward. So in our usability sessions, which will have more to come on Wednesday, part of one of the things we just need to get done was basically user and installation guides. I mean, that's just such an important feature and something that's often forgotten with software for most of the people on here who are software developers. That's the last thing that gets done. So we wanted to make sure and get that squared away. You're going to get a bit of an introduction to that today as we started to combine that with a number of tutorials. We've deployed a number of different interfaces, a new command line interface, but also a web-based interface where you can basically monitor the progress of the simulation as it's going. There's a little screenshot of it here, but basically you can then keep track of all the different things that are going on and extract information on it. If you've ever done some of these big simulations and you hit run and then realize that you don't have any way to see how it's going, that's a bad feeling because you don't know when something might have failed or you may have gotten a variable set wrong or something like that and watched it spin off out of control. So this is really designed to be able to watch that in real time and make sure that things are behaving the way that you want them to. There's a really cool feature that got created called the Try Helix on the website. So if you go to the helix.org's website, you can go on and just basically execute a number of small models against a kind of pre-canned set of scenarios. There's now a configuration options reference tool that basically both in code and in documentation kind of helps you reference to the most common configurations, the most common functions that you might use as you're starting to build your co-simulations. Think of that kind of like a little mini library that lets you kind of focus on the things that you need the most to get started. And as I mentioned before, we're starting to create some standardized domain APIs. So we're starting with a transmission and distribution model and a transmission plus natural gas models, where we're trying to build these kind of interfaces in a common manner. As a team, we've been gravitating towards doing this all in Python as an additional layer on top of the kind of Helix interfaces. And I say that specifically that these are additional layers because we're not saying you can't do whatever you want. We're not taking away functions. We're basically adding layers that will try to abstract out some of the lower layers so it becomes much easier to kind of put these tools together. You're always still able to go down as deep into the code as you want to, or whatever layer you feel the most comfortable engaging in, or is necessary for your use case. But if we can keep adding layers above it that abstract away a lot of the challenges around some of the software development and construction of the models, then that just makes it easier for people to get started and starting on these things. So really excited about these cases. This has been a really great discussion amongst the team to try to figure out how the best way to do that is. And then, as I mentioned, use cases, demonstrations of these use cases. These are kind of the piece that it's where as a power engineer, I get excited about. I get to see the kind of results and get to see the outcomes. We have a number that we built as part of our project, part of the Helix Plus project, which were designed really to help the team deliver on very specific improvements to the Helix software. So on our transactive and network microgrids partnered with WSU, Washington State University, we're basically trying to build out not only the way to communicate between these different microgrids and building the different control layers inside of it, which is already an exciting problem, but then extending that to different scales so that we can start to look at what does it mean to get to massive numbers of network microgrids and then being able to do that kind of co-simulation on a small HPC cluster. So that's really designed to then test out not only the different control systems there, but also test the software in a way that will hopefully stretch it a little bit, and we will find ways that will break the software and then improve it going forward. So that's going on right now. With our with NRECA, we're doing a distribution plus communications plus cyber anomaly detection project, which is a fun one because we haven't done a lot of cyber work with Helix yet, but more importantly, it's about this kind of ability to wrap in a real-time communication systems and be able to pull that piece in there and then push it across to a model in the distribution system. And so we're basically at this point then using that to test the throughput of Helix. So basically, can we basically fire at it, a big giant pipe of data, and can it move it around to the different simulators in the right way? Working on some commercial T&D convergence with our SIME partner here, which is basically trying to understand as we use particularly commercial tools, which are a little different. When we talk about the open source tool community, we're able to kind of open the hood, change things, and basically make modifications on the fly. Probably sometimes a little bit more than we should. But when we're talking about commercial tools, they are built and they are good tools the way they are. And what we're trying to do is find ways to interface with those. Sometimes we do have to work with the partners. In this case, to Eaton's been a great partner working with to improve the interfaces. And then find ways to basically then make it so that as we iterate across, in this case, the T and D boundary, what does it mean to converge and how often do you need to do so to make sure that your simulations work correctly? So that's been a really fun one to work on. Not only does it improve the Helix tool, but it also helps us lay out a pathway for how a commercial vendor might need to modify their tools to interact in this environment. We also have a natural gas plus grid techno-economic analysis. This is working with our Uncored partner and their Saint tool, and basically trying to find ways to look at this natural gas plus grid, not only looking at how to interface those tools in different ways, but then also looking at it from a validation perspective. So one of the things we're able to do is the Saint tool is able to do both natural gas and grid simultaneously inside of its system. But then we were able to then try to compare it and validate it against a co-simulated version of that, which allows us to say, like, what errors are we potentially introducing into the environment, and then how do we address those? On our transportation plus grid side, some exciting work going on there, particularly with our partners at Clemson, but particularly looking at trying to understand how do we introduce various different transportation tools, including Beam and Polaris, which are two national lab tools, to basically understand how do we look at these mobile agents in a system that when we're looking at it from a software perspective, it's not the same system every time. These agents are moving around the system and are interfacing with it at different places depending on where it's charging at any given time. And then our telecommunications and grid in real time. This is some work that's going on down at Idaho National Labs, interfacing with the Opal RT so we can drive some of these simulations down into real time. And by real time in this case, we do mean at kind of the microseconds time scale, and being able to interface that with grid tools. So a lot of things, as I mentioned, is designed to kind of not only drive interesting use cases, but also drive the technology and drive our tools to be better, expose where they're weak, and then help get more additional development to correct those problems. And then, of course, we have the community-driven. These are ones that, obviously a few of us are tied into, but and for the most part are driven by the needs of the community. And really, the sky's the limit here. We're going to go through a bunch of them tomorrow. I think really call it kind of a rapid-fire session. But there's things on transportation and grid. There's things on natural gas and communications, on DERs. There's things on ADMS and also an EMS interface. We've got some DERMS applications. We have stability around DER, transactive controls, and just a whole bunch more. And so, again, the whole idea around our sessions tomorrow is to just introduce everyone to everything that's going on in the community, and hopefully you can find some good interfaces where your use cases may line up with others, and we can start having additional conversations to help the overall community out. So what's next? Kind of at the highest level, we're looking to finalize version 3.0 and release that, I should say, very soon. We've got the beta out there. It's looking really good, but we're just just taking care of a few additional things. Over the next year, we plan to continue minor releases, but we also plan one more additional major release. And by minor, I mean, this is kind of bug fixes, and then we'll have one kind of minor overhaul for a 3.1 probably some point this year. Still planning that one out, what that exactly will look like. Got a lot of focus this year on validation. So there's a lot of kind of cool, lot of interesting questions around when you start to co-simulate all these models, are you actually getting the answers you expect? It's easy to get the technology to talk to each other for the most part, but then verifying that these models are giving you the right answer is also a very interesting part of it. And so we're going to be focusing on that over the next year. We're going to be testing and improving the scalability of Helix to larger models. And so we have a target that by next year, we'll be able to simulate a 5 million federate application. And by federates, what we do mean is kind of basically individual agents or simulators talking into the Helix kind of bus and being able to then communicate back and forth. We've had a lot of effort kind of improving our debugging features. We're going to continue those applications. You'll hear more about these over the next couple of days, along with basically engaging this user community to continue to build out additional usability features. These harmonized domain APIs, launch scripts, and web interfaces. We're basically just going to continue building upon those and making them better and adding things. We are going to try over the next year to do a multi-domain co-simulation across multiple geographic locations, in our case between different national labs, to see how that communication pathway between them affects our co-simulation. We already have done some small scale versions of this, but we have a goal to kind of really do some testing on this over the next year. By the end of this year, we really hope to have this real-time co-simulation with OpenRT up and running and demonstratable. And then, of course, about a year from now, we hope to host another one of these sessions where we can kind of share where we are and again, gather feedback. So that is really the extent of my content for today. I wanted to give some time to make sure that we can answer any questions. We do have most of the Helix Plus team on here at any given at this time. So any clarifying questions or just questions in general? Carlton, please go ahead.
Thanks, Jason. Really great overview. I enjoyed it a lot. I was curious about data consistency. So like if you have, say, like a natural gas model and then you've got a power model and you're co-simulating them, like how do you know that the two things that are talking to each other actually are the right ones to be talking to each other?
Yeah, that's a good question, and I'll ask anybody else to jump in after I give my kind of brief answer there. I think to the most part we're leaving that down to the user beware. So we're counting on you to kind of set up and know how you want to exchange information between the different models. I think what we're trying to add this year to that is basically ways of doing that diagnostic so that you can verify that for yourself. So that's what a lot of these kind of debugging tools are designed to do. Brian, go ahead and add. Seems like you have an addition to that.
Yeah, no, I think that was a great question. Thanks, Carlton, and also a great way to get started with that. It definitely seems like there's a lot to be left to the co-simulation designers to make sure that the signals they're claiming on either side are appropriate. Like if it's voltage, for example, on a transmission interface, that's actually connected to the right voltage place on distribution. I would also add that Helix has this co-iteration framework, which you'll hear a little bit more about further developments on that tomorrow, that sort of gets at a second question. So like one question is, how do you make sure that you put the right distribution system on the right node of the transmission system? And that's something that we're sort of relying on the developers of that use case to do right. But how do you make sure that the data on both sides of those boundary conditions, if you will, are consistent? The co-iteration framework allows time to stop and those simulators to go back and forth until they agree upon what that boundary condition is, and then advance time. And one of the use cases in particular, 4.3, the T&D co-iteration, is working on algorithms to help make that more sure to advance rapidly and to avoid sort of potential pitfalls of oscillations back and forth if there are sort of non-linearities that would cause it to have trouble reaching that equilibrium. I don't know if that helps, but.
Carlton, did that get to the root of your question there?
Yeah, that's really helpful. Thanks.
I think one thing I can add here is that when you are setting up a co-simulation, you can add units to physical properties, right? So a voltage And that does definitely help. So you cannot say connect the voltage with the kilowatt value if you set in the first place.
Thanks, Otto. I think we had a lot of background noise, so I'm not sure that quite came through all the way, but I think I caught most of it there. Looks like Lee, looks like you have a question there.
Yeah, I'll jump in. I probably should wait till tomorrow, but as a social scientist, I'm wondering, how do the people fit in here? That is, the decision makers, learning, manipulation, strategic interaction, pricing, markets, all that good stuff that we look at in economics. I'm wondering how you're viewing that fitting in with all of these with these federates and so forth.
Yeah, no, that's a great question. And I would say that's one we all struggle with right now. And by struggle, I do mean the fun kind of struggle, right? That's the research part. So at least the way I can say the way we've been viewing it is that becomes another agent or federate in the system. So, I know Brian could talk about some of the markets that they've been building to basically be a whole market that you could then represent into the Helix environment, where you basically have, the power system model plus the market model tied together. We could talk about some of the transactive simulation platforms that we've been working on, where users and people become basically representative equations or agents inside the system itself. And you can do those kind of in mass inside of a big simulator, or you can do those as little individual components. And I think we've been leaning more towards the individual components when we want to represent those type of things, just depending on how much interaction you want to have. So in the end, we're boiling down people to equations again, but at least in the perspective of Helix, that becomes really just an agent that we would then represent into the Cosimulation. Brian, did you want to add anything to that?
I think you summed up well. I'd say right now have a pretty good representation of the mechanics of markets, or at least if you choose to, right? So the point of Helix is it's really a framework that brings together tools that existed before. So when we bring in the tools that represent the multi-time period dynamics of a market, not necessarily dynamics in the power systems way, but in the idea of like people putting in bids, people doing transactive behaviors, different agents, like that part can be captured by bringing in different tools pretty well. I think you bring up an opportunity that we think Helix could also enable, which would be the idea of, great, we could also have, say, an agent-based model or individual agents themselves represented, and trying to capture a bit more of those non-idealities in a social science way. And that's certainly an area that we need to build up further, but the Helix framework would allow those types of things to be supported if you have another simulation engine that can capture those behaviors.
Thought I saw Phil. I think you were going to add something to that too.
Yeah, I would say some of the design we're doing in Helix with supporting dynamic federations and real-time control would allow an actual human interaction federate to be in place as well.
Thanks, Phil. Lee, did that get to your question there?
Sorry, I raised my hand instead of unmuting.
That's okay.
Yeah, as a first start, yes, of course, I'm involved in transactive energy system research myself, so I'm going to be looking forward tomorrow to seeing exactly how things are viewed. One thing I would worry about tremendously is manipulation. In other words, manipulability of any things you build into your system. Smart people sitting down, studying how to take advantage of that for personal or company gain or whatever it is, for a strategic manipulation. So the bigger the system becomes, the question is how fragile it is, how open it is to manipulation by people who understand those rules and then can turn around and do something specifically to further their own interests at the expense of society. So that is what that's a very hard issue. That's mechanism design. That's part of the big design picture of any design. And now you're opening up all these opportunities for people to see that design in detail for whatever purposes they have. So that's always going to be a problem. And I'll be looking forward to tomorrow to seeing how people might address that. Thank you.
That's great. Appreciate that. Looks like we got Wenbo.
Yes, thanks for the presentation. I'm a Helix user from Unreal. I have a question related to hardware requirements for Helix. So at what scale I should use a HPC versus my local computer? I'm imagining it has to do with my scale of my simulators. And are there any other requirements or general rule of thumbs? Thanks.
I mean, I think, general rule of thumbs, and I'll ask Phil here to kind of fill this out a little bit in here in a second, but, if you're getting beyond, say a few threads or a few simulators, you're probably going to want to move off of your local laptop. Each of these simulators that you might be using, plus Helix itself, will use some kind of thread in the system. So if you're doing, 2 or 3 federates, a laptop seems to be okay. If you're doing a few hundred, a server seems to be okay. And then, once you get beyond that, then you're probably looking at more like some kind of HPC application. Phil, does that feel about right?
Yeah, I mean, in general, each federate will use 2 or 3 threads. So, and they switch pretty well, but once you get beyond like 4 federates on a single laptop or something, it starts to slow. You notice it a little bit. Some of the workstation class can handle 100 without too much difficulty, depending on how much each individual federate is doing. But beyond that, you probably want to go to multiple machines or HPC systems. And we've run Helix on anything from a single core Raspberry Pi to large scale supercomputers. So.
Gotcha. Thank you.
And then Anjan.
I have a very general question on you've got 5 or 6 sessions going on this week. What is it? I mean, I have a feeling for what you're going to present in those sessions. I'm not sure what you would like to get out of that. I mean, what is it that you want as an overall? And in anticipation of your answer, let me ask also that if I was a user, since you're directing this to potential users, it's one thing to learn all the things you can do, which is very interesting by itself. But the question that usually comes up from a user is what things I can't do. That is, this is my problem. It doesn't quite match all the problems that you have already solved. How difficult is it going to be to solve my problem? Is it just a few Python lines of code, or is it going to be 6 months of coding before I get to do it?
No, that's a great question, and certainly throughout the different sessions, that's the amount of engagement's different, but we are expecting that, especially as we get into that usability and user sessions, we want you to ask those questions, right? So we want you to ask us, hey, I've got this idea, how close is Helix to getting there? I'd say most times we can answer that question in about 2 or 3 minutes to say how close are you. Of course, the answer itself may take weeks to implement, but for the most part, we've got the team that will be able to kind of answer that for you. So, but to get kind of back to your previous question, what are you asking from us? And it's going to be a little different on each session. So let me go back to the agenda here. So as I mentioned, these kind of first 4 sessions, they're really kind of us giving you information. We're basically kind of telling you what's going on, giving you some updates, hopefully building some excitement and things like that. These last 3 sessions are much more interactive. We want to give you some information about what's going on and what's new, and where we're going. But then the expectation is, or the hope is, that you will then say, that's great, but I have this idea. How would that work? And so then we can use that as a ability to start that conversation and have a additional conversation about what's missing. And so I'm hoping to see some of those things from that kind of bubble up to say, like, okay, great. It's wonderful that you're doing all this cool stuff on usability and users interfaces, but it would be really nice if I could do this. And so hopefully what we'll see is that over the course of the week, we'll get more and more as we'll get more and more conversational with the sessions and be able to extract exactly what those type of things. I'm not sure if that quite helps, Anjan.
Yes, it does. And I don't know how much time you're going to have on each of the sessions, but to have those conversations. But like you said, towards the end, it would be nice to hear those kinds of questions, issues.
Absolutely. Go ahead, Brian.
Hey, Jason, did you want to highlight? I know some of the members of this call are also on the TRC, sort of like I think we're also looking for kind of, are we on the right track from them?
Yeah, thank you. So yeah, and additionally, there's a closed sessions on Thursday that will be for our TRC, or Technical Review Committee. And so we'll have a set of questions that we'll provide you over the next couple of days to get ready for, to start thinking about. That basically is going to be a little bit more designed to kind of say, are we focusing on the right things? Do we need to focus on something different? How do we, are we going in the right direction? More kind of big picture, big direction kind of questions. Whereas these kind of usability and user sessions that are designed kind of more on the kind of the details, like, what's hurting you? What's making it so that you can't do what you need to do? And what can we do to help, type of thing. So kind of think of it at that level, is that, the Monday through Wednesday sessions are really kind of getting to the nuts and bolts. And I think the Thursday TRC sessions, which again is not open to everybody, is more kind of big picture. What do we need to do to make sure that this tool moves forward and becomes adopted?
Another vision for kind of what I think we saw this week is it's kind of like maybe three things at once, right? Maybe there's even more, but one of them is very much hey, you've never really used Helix, you've heard about this thing. What is it? What is it? What are people doing with it? What's going on? And then there's also the sort of update for both partners we already have, funding sources, as well as the users themselves on like what all is new and what's going on. And then the final is, as Jason mentioned, trying to get that feedback specifically from a subset of folks who are on the TRC in terms of making sure we're heading in the right direction. We'd love to hear that feedback from others too. We're just going to have a focus session with the TRC members.
Thanks, Brian. Let's see. Carlton, I still see your hand up. Did you have another question, or was that just from the previous one?
I think I don't know how to lower my hand, but I will ask another question.
Great, go for it.
If there's time allowed.
Absolutely.
So I think there's definitely, you pitched the idea of Helix as bringing together a bunch of co-simulation efforts under one umbrella and making it open source. And I think that's like a fantastic contribution. I was curious if you feel like there are also contributions on like the technical side in terms of how it was implemented or what's possible with Helix that wasn't possible in other co-simulation frameworks. And if you could just mention that perspective.
Yeah, absolutely. So I think I'll kick it over to Brian first to maybe talk about some of the interfacing techniques and things like that, and then kick over to Phil and kind of some of the underlying software elements of it.
Sure. Yeah. One of the initial ideas, as you said, we did indeed build off of some past work that was done by multiple labs. And just for clarity, I think pretty much all of those past efforts has now migrated to using Helix. So we've been successful in that regard, as you highlighted. But some of the unique features of the Helix design include, I'd say, sort of 4 things. One of which we talked about already, which is this idea of co-iteration before advancing time. The frameworks we'd seen in the past didn't really support that type of infrastructure for all types of space, and so that's a key enabler. Another one is this distinction between the physical values and those that might be more, we call them messages. And so just to put a context around that, the physical values would be things whose boundary conditions in physics would be already just happening. You bolted this wire to this other wire, or you've got this temperature on one side, so it's just going to happen. But because we have multiple tools, we have to make sure that those match in a physical space. And so we treat those a bit differently than things that look like control signals or human interactions, or even things that are coming out of sensors, which we consider as messages. And the explicit support for those as separate concepts has allowed us to treat those a little bit differently. Like, for example, you can add a delay to a communication signal, but you wouldn't be adding a delay to that physical phenomenon because those things are bolted together. So that distinction has enabled us to do kind of the next thing I was going to highlight, which is have these filters, we call them, whether that's delays or drop packets or messages or cyber attacks, or you can imagine any number of different things, could even be a full-scale communication simulation that can get in the middle of anything that's a message and simulate the level of fidelity your use case needs to capture those phenomena. Without changing the tools on the other side. So if you had a transmission simulator like a PSSE and you had a distribution simulator like a SIME, their models don't have to change at all, but you can sort of transparently first pass the things like messages, control signals, for example, prices directly, or you can start putting in more and more delays or errors or noise or things like that without changing the underlying pieces in the front. So the combination of all those is unique in terms of the interfaces. I'll turn it over to Phil for the kind of back end side of some cool stuff too.
Yeah, I think Brian mentioned filters, and I think some of the key differentiators that makes Helix a little different than some of the other things we've seen are, one, the use of filters and the separation of the value and message interfaces. But another one is the use of a distributed timekeeping. So there's not necessarily a central timekeeper in the system, and that allows us to achieve a potential for scale that is not available in some of the other co-simulation frameworks. And I think keeping those two things and putting them all together, I think is what differentiates Helix from the other co-simulation platforms that exist.
Phil, did you want to highlight the hierarchical broker piece as well? I think that scalability might.
Yeah, I think that's part of what I consider the distributed timekeeping portion of this, but we can allow brokers at multiple different levels. So there's not just a single broker that coordinates everything. You can coordinate things at different levels in the co-simulation. And that gets into the hierarchical nature of the name of Helix, is that we put things in layers. There's a low-level layer for the operating system components and dealing with the comms, and then a core API, and then an application API, and then building on top of that is the domain APIs and kind of global controller things.
Thanks, Phil. And I think you got it. To me, at least, I think you got it to the key element for me is that it's the combination of all those things, and the idea that we've been really trying to build this not as a very, very generic co-simulation tool, but as a co-simulation tool designed around the energy space. And so we're implementing the features that are most useful for our kind of co-simulation in that area. And so all those unique features coming together, I think, is really the kind of the strength of it. Lee, please go ahead.
Oh yeah, I just have another question from what you just said. With agent-based modeling, there's a very interesting parallel use here. One is you're representing a system. The other is you're actually building the way the system works. In other words, the actual agent-based model is the implementation of the system. And so when you talk, now I'm wondering, are you ultimately thinking that something about Helix will be actually implemented in the real world as the way these federates, as you call them, actually interact? Or are you just trying to represent the way interactions occur in the real world without you yourself proposing the design or implementing the actual implementation? So this is, agent-based modeling allows you to synthesize or represent. And now I'm just wondering, from what you just said, whether you're actually going into synthesis, not just representation. So I'll get off and let you answer that, maybe.
No, that's a phenomenal question. And so, at least from the perspective of Helix, the tool, we're really about the kind of more the just enabling perspective, right? We're building about pathways that these things can communicate with from each other. That said, every person on this team is also excited about the research part of it. We're building a tool because we need a tool to answer questions. And so I think what Helix does is enables us to learn some of those other kind of pieces about how should it be implemented. We can then explore different pathways by using the way that the tool is built to verify that and things like that. And so I think from a design perspective, it's the first. It's trying to say like, hey, let's just be able to get these things to talk to each other. But the effect of that means that we get to do some of that really cool stuff to say like, yeah, but that's not the best way we want these things to interact, and how can we do it better? Go ahead, Phil. Oh,
No,
sorry.
I don't have anything.
Okay, go ahead, Brian.
No worries. I just had a quick addition that I think there's multiple aspects of that building something as it could be. One is, as Jason described, we certainly can think about whether those structures make sense. I think in a sort of practical engineering sense, there may also be opportunities to have Helix be the glue in operations for grid space too. We currently don't have those in place, but there's a number of opportunities where something like that could make sense as you start to think about future sort of more technical operations, in addition to the more sort of agent human type interactions that I think you were scratching at there, Lee.
Great. We are past our time here by a few minutes, so I think it's probably good for us to go and wrap it up. I really appreciate everybody making this first session. We'll have our next one here in about an hour. That will be kind of Helix 101 for anybody who'd like to join us for that session. Otherwise, thank you everybody for joining, and we will see you throughout the week.
Thanks everyone. Thanks, Jason.
All right. Thanks a lot.
All right. Thanks, everyone.